Welcome to Spring LIB.
In this exercise, we're going to be talking about circular motion, so I'm going to briefly review the concept. Consider that we have a particle that's undergoing circular motion, as shown in the picture, and we can decompose the particle's acceleration into two components. One of them is the centripetal acceleration, ac, and the other one is a tangential acceleration, at. The centripetal acceleration accounts for the change in direction of the velocity and is equal in magnitude to v squared divided by r, and it points towards the center of the trajectory, while the tangential acceleration accounts for the change in speed and is equal to dv dt. What we have in the exercise is an airplane that's traveling with a speed v of 50 meters per second, and the airplane is tilted, as shown in the picture, by an angle theta of 15 degrees, and we have a pilot who only feels the force of the seat, the normal force that the seat exerts on him, and the pilot has a mass of 70 kilograms. Okay, and our goal is to find both the radius of curvature rho and the normal force of the seat exerts on the pilot. So what I'm going to do is to draw a force diagram. So consider that this here is the pilot. Okay, I'm just going to represent it by this rectangle. And according to the figure, what we have is that this angle here is 15 degrees. Okay. Notice that the forces that act on the pilot are the gravitational force and G pointing downwards, and also the normal force N. Okay. And I'm setting up a coordinate system such that the y-axis points upwards and the x-axis to the right. Okay, so in the y-coordinate, Newton's second law tells us that, and before anything else, notice that this angle here is 15 degrees. So this means that in the y-coordinate, we have n times sine of 15 minus mg is equal to 0, okay, because we are assuming that the only force that the pilot feels is the normal force, so the gravitational force must be cancelled out. And in the x direction, we have n cosine of theta is equal to, according to Newton's second law, n times the acceleration, the centripetal acceleration, because the centripetal acceleration is pointing in the x direction, since the x direction is the direction of the center of curvature. And the acceleration is v squared over r. From the first equation, we can find a value of n, so n is mg divided by the sine of 15. M is 70 kilograms, g is 9.8 meters per second squared, and we have to divide it by the sine of 15. So n is equal to 2,651 newtons. And then we have to find the radius of curvature, which I wrote as r, but the exercise calls rho, so let's be consistent with the exercise. I'm going to take the equation for the x-coordinate and isolate rho there, so we have that rho is equal to mv squared divided by n times cosine of 15. Now m is 70 kilograms, v is 50 meters per second, and we have to divide it by 2,651 newtons times the cosine of 15, which means that rho is equal to 68.3 meters. And this is the radius of curvature of the path of the airplane, which concludes our exercise.